corticospinal tract, you know that it decussates. Not all the fibers, 80% crossover, and they form the lateral tract. Okay, 10% which don't decussate again form the lateral tract, and the 10% which do decussate form the anterior tract. She'll talk to you about the lateral anterior tract. Okay? She'll make you understand what all that means. Trochlear nerve decussates, you know that. Facial nerve is a bit special. I don't know if you need to know that. Do you need to know that? What? About the facial nerve decussation.
It's, you mean from the brain, is it?
No, that upper part of the head.
No.
Yeah, so you can leave that out, it's fine. It does decussate, but it has a special way of decussating. You'll learn it in 4th year. Okay? If you're interested in the end of the class, you can ask me. But you don't need to know it. But trochlear nerve is important. Okay? And there are other motor neurons that decussate after joining the spinal corticospinal tract. Okay? That's in the brain. They decussate in the medulla. You know it, yeah? The pyramids, they decussate. Next. Now brainstem syndromes. Do you remember the picture of the brainstem I showed you? If you know that picture, you can know all the syndromes. Basically, it would be a lesion of the nuclei in the brainstem. I showed you several nuclei. I talked to you mainly about the motor nuclei, but there are other nuclei as well. In brainstem syndrome, other nuclei are also involved. Like the trigeminal has the motor nuclei of the mouth. Besides that, it has other nuclei like the sensory nuclei. Your sensation of your face is by a trigeminal nerve. So that will also get affected. Okay? So basically, it's brainstem syndrome. It's part of the first question. Yeah? It's central paralysis and brainstem syndrome. It's one question for your exam. So I talked to you about central paralysis. If you say what I said, that's enough. Brainstem syndrome is basically a syndrome of the tracts and nuclei in the brainstem. Okay? Not the nerves. The nerves come to peripheral paralysis. Not the nerves, but before the nerves, the nuclei and the tracts that interconnect those nuclei. Okay? So, and cranial nerves are involved because the nuclei are involved, obviously. The nuclei is involved, the cranial nerve is involved, but not because of a problem with the cranial nerve. Okay? And then there are tracts. These tracts are present in your brainstem. Because all the tracts, before they go to your brain, they have to pass your brainstem, obviously. So, there's a corticospinal tract in your brainstem that continues to the motor cortex. Yeah? So, there can be a problem with your corticospinal tract. This is how they are arranged from the medial side to the lateral side. The medial side of the corticospinal tract controls your eyes, and it's not so important, there's no the corticospinal tract. Okay? And the spinothalamic tract, which controls pain and temperature. They also, where do they end up? Where does this tract end up? It goes from the spinal cord into the brainstem and ends up in the
Which cortex is responsible for sensation?
sensory cortex. Yeah. So they end up there. Okay. And this I didn't highlight it, but this is about this. Okay. The spinothalamic tract, they decussate in the spinal cord. Okay. Are you talking about that?
Yeah.
So she'll tell you about that. Now the posterior dorsal column. Okay. They control other sensory inputs like 2-point discrimination. That's your ability to discriminate 2 points. Like if a person puts 2 fingers on your hand, you know it's 2 fingers. If you have a problem with this, when you put 2 fingers on your hand, you wouldn't feel it. Your back is less sensitive. If you put 4 fingers on your back, you might actually feel them as 1 finger. But your tongue is more, or your lips are more sensitive. Put 4 like that, you can say there are 4 by closing your eyes. Yeah. So that's what 2-point discrimination means. Light touch is light touch. Yeah? Just the sensation of touch. And proprioception is your body telling you what's going on with your body. Like when you walk, are you maintaining your balance? That's why your body is always making minor adjustments to keep you straight. Okay? Humans are walking on 2 legs compared to other animals. So we have more proprioception because we need more control. We have less stability with 2 legs than 4 legs. So that's important. And all this is controlled by the posterior cord of your spinal cord. She'll talk to you about that. And they also go to your brainstem and end up where? Again, sensory. They're sensory, so they end up in the sensory core. postcentral gyres, okay? So these end up in the postcentral gyres, and they cross over in the medulla, okay? It's not very important to know, but they cross over in the medulla, and they form the medial lemniscus, okay? And the spinal thalamic tract joins the medial lemniscus, and they go together to the postcentral gyre, okay? So yeah. And so upper brain and upper and middle brainstem would involve the third nerve to the sixth nerve, because you know it in order. You don't have to by heart anymore. You know it's already set in order. Yeah. The middle would involve the seventh to the 12th, middle and lower. Okay. And finally, there's a separate category for lower brainstem because they are more common, just the lower part. And there are two syndromes you should know: bulbar palsy, pseudobulbar palsy. Basically, bulbar palsy is lower motor neuron lesion of 10 to 12. Okay, that's the cranial nerves. These cranial nerves are involved in bulbar palsy. Pseudobulbar palsy is upper motor neuron lesion. The nuclei of the same nerves are involved, and that would cause pseudobulbar. Okay. Now we move on to peripheral paralysis. I told you peripheral paralysis is because of cranial nerves and spinal nerves. So, due to lesion of spinal nerve, cranial nerve, and their branches. Okay. How many spinal nerves are there? 31 pairs. And cranial nerves? Okay. So, and it's a lower motor neuron lesion. Now, the lower motor neuron lesions have their own specific signs, and I'll talk to you about them. But now you understand what I mean by lower motor neuron and upper motor neuron, don't you? Yeah, you understand? So, if you understand that, it's fine. So, first of all, muscle weakness. This is the only symptom that's in common with central paralysis and peripheral paralysis. Muscle weakness, because both are paralysis. Okay? Now, in this case, it's not spasticity, it's flaccidity. Okay? Because I told you the alpha motor neuron keeps firing. Okay? They keep firing. Now that connection is gone. The central connection is still there, but there's no use of the central connection if the peripheral connection is not there, because it's one wire. So a problem anywhere would cause a problem at the end muscle. In the first part, it's not one wire, sorry, it's several wires and several nerves. Central paralysis, that inhibition is gone, but the alpha motor neuron from the spinal cord keeps firing anyway, because that connection is intact. Yeah? In peripheral paralysis, that's the nerve that's affected. Your inhibition is there from the motor cortex, but it doesn't matter because you need the final nerve to go to the muscle for the inhibition. Yeah? So you can forget the whole inhibition story, but you can remember that I told you the alpha neuron keeps firing, that connection is gone, firing is gone. There's no more firing and the muscle has no more tone, so it's flaccid. They just hang. These muscles hang. They don't have tone to them. They just hang because that impulse is gone. I told you in the other one there is presence of spastic reflex, here there is absence of spastic reflex. Now, muscle wasting. The previous time, alpha motor neuron kept firing, so there was a tone and your muscle was being used a bit even though you're not using it. In this case, that's gone. Completely gone. So the muscle is not being used at all. So it starts to atrophy immediately. There is no impulse. Fasciculation and fibrillation. Because your muscle is... Now, I didn't tell you before why there is fasciculation and fibrillation. Now I'll tell you. Here there is fasciculation and fibrillation because when your alpha motor neuron is cut and your muscles begin to atrophy, the muscle itself gives sparks of current, and that's why they vibrate, because the muscle is atrophying. When it's atrophying, it automatically does that physiologically. Okay? That's why there is fasciculation and fibrillation. In the other case, there was no fasciculation and fibrillation because it wasn't atrophying at that rate because of the alpha motor neuron stimulation. Finally, hypoactive reflexes, because your reflexes depend on the peripheral nerves and the spinal cord. Peripheral nerve is cut, there's no reflex arc anymore. Yeah? You know the reflex arc, yeah? There's no reflex arc anymore, so these people have no reflex. When you do that, it doesn't at all. And told you the peripheral nerves involved. These are the peripheral. First of all, they involve the cranial nerves. I'm not talking about them because I already talked about them. If there's a lesion in any of your cranial nerves, it would cause peripheral paralysis. But if there's a lesion in the nuclei, it would cause Now, these are your spinal nerves. Yeah, I'm concentrating only on the motor part. Yeah, there's a sensory part as well. And if there's a lesion, it's not very simple because your spinal nerves, before they go to the main muscle, they bunch up. As you can see, you learn this. Yeah, they bunch up and they divide again. They bunch up, they divide again. Finally, they form the end nerves. Okay, so it's not as simple as saying C5 is axillary nerve. It's not, because there's C5, there's a bit of C6 going into it, and a bit of C7 coming in later. Okay, so if there's a problem with C5 spinal nerve, what would it affect? It would affect your axillary nerve, because there is a part to play for your axillary nerve. It would affect your median nerve as well, because it comes from your median nerve. But you don't need to know all that. I'm putting this picture here to tell you that you have to know, depending on where the lesion is, what is affected. Okay. Now, if your radial nerve is affected, it's straightforward. Your radial nerve controls your triceps. Okay. So if it's affected, you would have paralysis of the of the triceps. Okay. So if you go further, the posterior cord forms the radial nerve end. So if there is a lesion of your posterior cord, it would affect your triceps and your shoulder, because your axillary nerve controls your shoulder. Now you go even further to the nerves. Yeah. If just C8 is very rare. If only C8 is affected, there wouldn't be much of a problem, because there would be stimulation from D1 as well, because both come together. Again, if only C7 is affected, it's not such a big problem, because C8 and C6 would compensate for it. Okay? So that's why I put this picture here, for you to understand that in peripheral nerves it's not as direct, okay, as cranial nerve. Cranial nerves is direct because one cranial nerve has a specific function. That's it. But for the spinal nerves, it's not like that. Except for the thoracic nerves, they are a bit more understandable, because T3 would affect the area of the third and fourth rib. T4 would affect, because they don't branch like this. This is which plexus? Brachial plexus. And these plexuses, they combine and uncombine, and it makes it more complex. Okay, you don't need to know it in detail, but know that it's not so simple in these areas. In the exam, you can just mention that there's a different effect for the end nerve, but there's a different effect for lesion of the spinal nerve. Okay, and this is your which plexus? Lumbar plexus. Yeah, it's the same. As you can see, the end nerve is formed by mixing and matching of the spinal nerves. It's the same. And again, you have your sacral plexus. Okay, and they also have the same property. Yeah. Now paralytic syndrome, the last question. First of all, you know what is paralysis? Is complete loss of strength of a muscle or weakness. Okay. Now there are types of paralysis. There can be paralysis of only one limb, only your upper limb. When would that happen? If there is a lesion where, for example, brachial plexus. If your brachial plexus is completely gone, your upper limb would go. Yeah, that's called monoplegia. Just one limb is gone, monoplegia. Okay. Then there is diplegia. If both your brachial plexuses go together, it would cause diplegia. But again, that's very rare for both to go together. Now, hemiplegia. Hemiplegia means like this, cutting your body in half like that, and this half of your body completely being paralyzed. Your right hand and your left hand, left leg. It would happen if there's a lesion of both your brachial plexus and lumbar plexus, but that never happens. Okay. When that happens is, I told you about the motor cortex. Yeah. So if there is a problem with one whole motor cortex, suppose there's a problem with your left motor cortex. Okay, your motor cortex is destroyed by a stroke. There is no blood supply and it's destroyed. So you would have paralysis where? On your entire right side, because your motor cortex controls everything on your right side. So this is when hemiplegia occurs. When there is a problem with your motor cortex, the opposite side, the complete side is paralyzed. Okay. Paraplegia is more common. Paraplegia is when you divide the body like this. Hemiplegia is when you divide the body like this. Paraplegia is when you divide the body like this. Okay? So your lower limb is affected, but your upper limbs and your trunk are.
Would there be issues with the sensory as well?
Sensory? Yeah, sensory will also be affected. Okay? She'll talk about it. sensory will also be affected, but in a similar way, but she'll talk about it, don't worry.
So like,
I'm talking about paralysis, so I'm just talking about motor. Yeah? Okay? So yeah, hemiplegia is when it's divided like this. Paraplegia when it's divided like this. Okay? So your lower limb is gone, but your upper limb is fine. And finally you have the worst one, quadriplegia, when everything is gone. Okay? That can happen either if both your cortexes go, which is quite rare, but it can happen if there is high enough lesion of your spinal nerves. Yeah? From there, if the spinal cord is cut in the neck area, everything would go, because it's from there that all the nerves come, all those connections go. So none of your limbs work. Quadriplegia. Quadri means 4. And finally, this is the last slide. In Paralysis syndrome, we can talk about the level of the lesion on the spinal cord. Okay, it's important. So first of all, is your phrenic nerve. That's important. Which spinal nerves form this phrenic nerve? C2, C3, C4. Okay. So if there is a lesion above C4, you would have quadriplegia. Lesion means the whole spinal cord is cut at that level. Okay. So if there is a lesion above C4, you would have quadriplegia, because none of your other spinal nerves will work, because the connection is spinal nerves will work. Sorry, but it's by the way, if the peripheral nerves are cut, it's lower motor neuron lesion and central paralysis, peripheral paralysis. But if the spinal cord is cut, it's central paralysis. Okay, so this is central paralysis. Remember that. So if the spinal cord is cut at the level of your neck, yeah, there would be paralysis of all your muscles below the neck, yeah, because the corticospinal tract is cut, and most importantly, the phrenic nerve wouldn't function, because that's also cut. So these people would not be able to breathe, and they would need ventilatory support, otherwise they would die. They would need artificial breathing. So a transection of the cord above C4 level is lethal. Okay? So it could be the respiratory paralysis, they can't breathe, and it could be quadriplegia unless you put them on a ventilator. Okay? Now, C5 to T1, what makes up from C5 to T1? These nerves form the brachial plexus. So if there is a lesion from C5 to T1, your respiration would work, because C2 to C4 is where your respiratory muscle comes. So these people can breathe, but they would have problem with the upper extremities and everything underneath as well. Okay, that's how the spinal cord works. From the level of transection, everything below that also will stop working. Okay, so and depends on where the lesion is. If there's a lesion at C5, so their upper limb would be almost functionless. But if the lesion is lower, like T1, C5, C4, C5, C6, C7, C8, all these are working, so they would have some function of their hand. So depending on the level from C5 to T1, they would have varying degrees of losses of upper limb. Okay? About C6 is not so bad, because then they can use their shoulder and their wrists. T1 is okay, it's not too bad, because they would have almost all function, except maybe the fingers might not work very well. But their lower limb would be paralyzed completely. And also the muscles in their thorax and abdomen, because they are formed by the thoracic spinal nerves, T1, T2, yeah. So all of this would be paralyzed, but they could use their hands. But if it's higher up, they wouldn't use their hands either. Understand? Now T2 to T12, they would have their hands, because up to T1 it's fine. Their hands work perfectly, but they will have varying degrees of losses of trunk and abdominal muscles. Okay? And of course, paraplegia, again, the legs would be gone, because everything underneath is also gone. So depends. Like if it's T10, they would have more functioning of the trunk and abdominal muscles, and if it's T2, they would have less function, because depending on the level. L1 to S2. Now L1 to S2 form your sacral plexus, lumbosacral plexus. Okay, so they would have all these functions up to the abdomen, but their legs would be off. Yeah, and it depends. L1 they would have complete paralysis of the leg, and at S2 they would have more function of the leg. The lower it is, the better. And finally, S3 envelope. S2 is the last branch that gives you any motor supply. Okay? From S3 onwards, they will have no paralysis because all their motor nerves are intact. But what S3 supplies is, it supplies your sensation in your groin area and like your urinary function and stuff like that. So they might have a bit of incontinence and sensory loss, but all their muscles will function fine because from that below there is no muscular function. Okay, that's it.